thanks, Julia, and for all of you to be here today. Thanks for including me in this series. It's an honor to be in this room talking with you all because I did spend many years here in Seattle and came to many a Bevan series talk myself. And so it's great to be back here. And thank you, David, for all of your hospitality and helping me get through today. So yeah, as Julia said, I am here today to tell you a story about maybe something that has been in the past considered a non-traditional data stream. It's becoming more and more, that story's changing pretty rapidly actually, so we'll talk about that a little bit today. But first I want to give you a little bit of the scope of where citizen science, this term, which I'm going to use citizen science, but it's called many different things. Participatory research, volunteer monitoring, citizen, civic science. There's all these different terms. There's a whole papers written about what terms are right for what scenarios, but today I'll just generically use the term citizen science and thinking about, well, what does that actually mean? So if you just Google definition of citizen science, this is what you get. The collection and analysis of data relating to the natural world by members of the general public, typically as part of a collaborative project with professional scientists. That's a pretty good encapsulation. Interestingly, citizen science, the term was added to the Oxford Dictionary in 2014. It also made its way into a lot of some White House documents last year, kind of formalizing the need for citizen science. I found this very interesting. There's several encapsulating papers that have come out the last couple of years about the process of creating citizen science. And McKinley et al. Made this statement that I often describe to people, and it's about the fact that it's not citizen science and real science, or citizen science and traditional science. It's really often, not always, but often indistinguishable from more conventional projects and data in that it can use a variety of different methods, achieving a variety of different goals, basic research, management, policy, conservation. It just happens to engage a different group of people. And who are those people? Well, citizen scientists, of course, are those who are voluntarily, usually without compensation, and often spending a lot of their own money, voluntarily contributing their time, effort, and resources towards scientific research. It really is tapping into the natural historian in many of us. It's the wanting and capitalizing on the desire to be around other nerds. And I say that with all of the best intention. It's the wanting to notice more, participate more, be a meaningful, spend your free time, your recreation time doing meaningful activities. So kind of taking yourself to the next level. If you know a fanatic bird watcher, you know what I'm talking about. We get the same kinds of fanatics in the fish world, they're called. So they can range across a whole spectrum of gender and age and background, academic background. So citizen science is definitely not new. This is a really cool paper that was put out a while back, 2009. So the image on the left is from some emperor journals, basically, from during the cherry blossom festivals that happened in Kyoto each year. Going back all the way to the year 850, they went through and cataloged, and they would note in their journals when the first bloom of the cherry blossoms would happen and when the peak bloom of the cherry blossoms would happen. And so there was a group that went through and culled all those dates and data and looked at the flowering date, the peak flowering date through those years, and you can see just in very recent times that the peak flowering date is getting earlier and earlier. So a great example of, and that's often some of the early examples were people walking through their yards, noticing when flowers were first blooming, when birds were starting to fledge. A lot of that phenology, nowadays there's huge citizen science programs that revolve around that. So long history. A little more recent, lighthouse keepers are one of the, this is a log from in the 1800s. They were keeping weather data every day in their logs. They weren't scientists, they were lighthouse keepers, often women, and keeping logs of weather events and basic stats about weather. All of that data has been archived through archives programs through NOAA more recently, and then Walden Pond. So looking at some of the earliest in the 1800s, recording first ice breaks, first ice appearing, and then when the ice started to retreat each year, and looking at weather and climate information from there. So definitely not a new idea of non-academics collecting data. I kind of think of the evolution of the more modern era of citizen science as the Christmas bird count. That was Christmas Day, 1900. There were 27 participants and they counted 90 species of birds. It was a result of people starting to notice that there were declines in bird species, and there was a big fashion statement that was happening with women putting more and more ornate feathers in their hats, and a couple of groups up in the Northeast tried to start to decide they could go out and count as many different birds in different locations. So this past year, it now is not just one day, it stretches over about 20 days. About 77,000 people counted 2,600 species, and arguably probably one of the longest continuously running citizen science programs out there. And most of what we know about bird trends and populations come from this program and other bird watching citizen science programs that have happened through the years. So jumping forward, so this is kind of laying the foundation, and really in the last 20 years, citizen science as a field, as a term, has blown up. It really only, the term was coined, I didn't realize this, but by two people kind of coincidentally at the same time. They didn't realize each was working on the other, but in the early 90s, the idea of citizen science, that term was first used in the literature. And today, there's over, if you look on cataloging sites, there's over 1,100 cataloged citizen science programs in existence of all different things. So not just natural history, looking at monarch butterfly distributions. That's a monarch with a tag on it, a huge volunteer program that enables volunteers to tag monarchs and look at distributions. Water quality, stream monitoring is a very large component of citizen science, often engaging children. It's a perfect opportunity to to build in education into a pretty rigorous data collection effort. There are a lot of bird monitoring programs out there, Nest Watch, many different ones out of the Cornell Lab of Ornithology. But then not natural history ones. There's all sorts of ones about astronomy and looking at data from the universe and helping identify points of interest on photos. Looking at how proteins fold and trying to come up with the best ways for folding of proteins, basically gamifying science to the people who are sitting in their living rooms. So a whole breadth of things, earthworms, and you name it, there's probably a citizen science program for it. There's also been a large coalescing of almost like matchmaking for people who are looking for citizen science. There's now websites you can go and put in your interests and find a citizen science program that might be good for you. There's also websites that are allowing people, if you want to start your own and you don't have the resources to build a database or find the volunteers, it allows you to basically plug and play and create a online form that you can then use. So really interesting things have been happening. You guys have one of the longest running ones here. So a lot of these are terrestrial based or up in the weather, atmosphere, astronomy. But there is a smaller group of marine based ones, and of course, Coast has almost 20 years under the belts and almost as long as Reef, and looking at capitalizing on those people who have a really special personal connection with a coastline. They're walking the beaches every day, and they're noticing things. And being able to use those people to have that connection with a very place-based connection to document originally beach cast birds, so birds that had washed up, but more recently marine debris, human use of beaches, documenting what kinds of impacts are happening. And those, I love that. I was looking at your information on your website, and this science is a team sport, because there's a whole range of how involved the volunteers are with scientists. And some are a little more co-collaborative than others, and they really have, volunteers working really boots on the ground with scientists, making it a team sport, and it is really about that place-based for them. And they own that. I was talking to one of the staff today, and it's really, if somebody else comes in and that stretch of beach is already taken, it can be, they have ownership over that, and they feel like that's my stretch of beach that I'm monitoring. So it's not just terrestrial. There are some marine ones, and that's one here. So advantages of citizen science. So why would we look towards this maybe non-traditional data source to maybe revolutionize, help us answer some of the pressing, previously maybe unanswerable questions in conservation and marine science and sustainability. So it has the capacity to collect data on scales that would otherwise not be possible, both geographically or over time. So the Christmas bird count is a great example of very consistent year after year data collection on birds. The amateurs are often becoming like the pushers of the field. We're losing taxonomists. Field biology is getting more expensive. So having this team of people who are interested are helping fill those gaps, but also they're pushing the envelope and trying to find new things, discover new things. As with the coast example, it really does provide an authentic learning experience for people. So it's not just learning about environmental education from a classroom, kind of getting them into a meaningful connection with nature. It also, of course, that feeds into this public participation in the process of data collection and conservation policy questions that they would otherwise probably not have. They have the first-hand view of what's happening in their environment, and it's just another tool in the toolbox of data sources, data streams that can then be used ideally to better understand resources that you would otherwise not be able to do. So some advantages, lots of advantages. There's some disadvantages, as with any, or challenges, I guess. Developing a program with some intentional design, some thoughtfulness about how the data are going to be collected, how the data are going to be managed, and then used. Someone that I spoke with today encountered those challenges on the first try and found that with all good meaning, they tried to go out and do a data collection program with some volunteers and just wasn't thought through quite well enough, so it didn't work out. So trying to head those challenges off with some intentional thought about all the way through the process. Unfortunately, there has been a fair bit of work in the field to help people with toolboxes and publications on understanding outcomes, learning outcomes, database structure, so that you can ensure that you're going to end up with data that's usable. Funding is an issue for everyone. It's not an issue that's unique to citizen science, but certainly a lot of citizen science programs are run by nonprofits or within academic institutions, so there's always funding that's being sought. And then finding and training volunteers. So you want to find ones who are really going to do good work and collect the data, but you also want to keep them and keep them coming back. And then finally, probably the biggest challenge that has always been there but seems to be getting a little less is securing buy-in from people who you want to use the data, putting the data out there and making sure that the data are valid and useful and needed so that it will get used, so that those volunteers keep coming back and doing it. So in spite of all the challenges, as I said, there's been a lot of, it's kind of the tipping point, I think, for citizen science. The coming of age, so to speak. So there, in that same paper that I mentioned earlier, McKinley, it was in Issues in Ecology, and they looked at the number of peer-reviewed publications that have come out about citizen science or using citizen science data. There's been a huge uptick in the last 5 or 10 years. There's more recently a whole professional association that's formed about citizen science. There's a new peer-reviewed journal that came out of that association. So lots of, they have a conference now every other year. So lots of momentum towards this field. So that's kind of how we got to my story that I'm going to share with you today, which is about the Reef Volunteer Fish Survey Project. And the idea was to provide an opportunity for divers and snorkelers to do something for, so very similar to what the birdwatching world got out of the Christmas bird count. Is, you know, we've got all these people who are getting in the water and going through the expense and the time of putting their face in the water, thousands of people all over the world every day. They obviously have a keen interest in looking down there, so let's capitalize on that and capture some information from them. And so it came from the very early notions of, well, so it could be fish watching instead of bird watching, and they could record all the species that they see, just like a bird watcher would, because there's very little that was, at that time, 1993 is when we started, very little was known about basic distribution and abundance. At the time, we were working in South Florida of tropical Western Atlantic, of Caribbean fish species. Where are they? Are they, you know, equally widespread throughout the Caribbean basin? Are there hotspots of diversity? And trends through time. So maybe, you know, are some declining through time? So very basic information. There wasn't really any other, we want to know this. We want to be able to answer this question. It was just a broader sense, and so how did we get to where we are today? Because it was kind of well, we could have it like on a napkin maybe at the end of the dive, and it would get mailed somewhere. Because remember, so 1993, here we are, almost 25 years ago, and there was no internet, there were no websites, really, barely yet. There were certainly no smartphones or cell phones for that matter. There were no cheap, inexpensive underwater cameras. You know, so it is a little bit of a miracle that we that we succeeded and got to where we are today. And fortunately, it was with a fair bit of that intentional design. There was it was motivated by divers. That whole idea, it was divers and underwater photographers who were working on a fish ID book, who had that, like, let's do fish watching, bird watching, but for divers. They got connected very early on with some scientists, practitioners from the Southeast Fisheries Science Center, University of Miami, Rasmus, and the Nature Conservancy, and got a really good little group of people together to help figure out how do you go from, yeah, let's have them write it on a napkin and mail it somewhere, to what's the methodology going to be to produce usable data, but can be done by a wide variety of people in a wide variety of habitats, with the least amount of restrictions so that it's still fun. And then what happens to the data after that? And so really, through a whole summer of field testing, it got off the ground, and it's blossomed from there. The methodology that was created is called the roving diver technique. It was based on non-point, you basically have free swimming range. And the idea behind this was we wanted to be able to have an activity very similar to bird watching, where you're doing your activity just like you would already. So we didn't want to have a lot of heavy equipment intensive, didn't want to make them go one straight line. And going back to that whole idea of the people who are going to do this and keep doing this are looking for They want the mysteries. They want the fun, the finds that keep them coming back for more. If you just had this little restricted list of things that they could record information on, they'd kind of do that and pretty quickly, okay, I did that, I'm done. But me, I can tell you, even still, I've done a lot of surveys in my time, and I still find stuff I don't know what it is on almost every dive. So there's always stuff to discover, and that's kind of one of the things that has made a lot of the citizen science programs successful, because it does have an element of fun to them. So yeah, you swim around, you record all the fish that you see, and then you record a relative abundance, a log scale category, and then you submit those data to Reef. There's a whole series of scaffolded error checking, quality control points along the way. There's also an experience level rating that we developed very early on that allows us to encourage everyone to start with surveying. So we don't really, there's no minimum experience or minimum training that people have to do. There's a lot of different avenues that they can do to get into the program, but we do have a way to capture the experience of those surveyors so that we can incorporate that on the back end during data filtering. The general method was field tested and was published in the Bulletin of Marine Science in 1996. And so we started in 93 in South Florida, and this is our map today. So as you can see, we're conquering the world, one region at a time. We're actually currently working on the Western Indian Ocean and Red Sea, and then we'll be good for a while, I think. And so that same method, our same basic survey materials and training sets happen in every single region. So it's allowed us to kind of modularize. Obviously, the fish are different. We also, in temperate regions, so out here, along the whole west coast, up in the northeast, and in the South Atlantic states off of the Carolinas, those also, in addition to fish, we're really primarily fish people, but we did realize that there aren't a lot of fish in those regions, so we incorporated a set of invertebrates. Those invertebrates, unlike the fish, which was anything that they could see, the invertebrates were selected with guidance from regional scientists and agencies to come up with some short list. It's about 50 keystone species, recreationally important, those that might be threatened by gear impacts. Out here, there's the cloud sponges are one of them, and some that are just really fun to look at, like nudibranchs. So a little cross-section of invertebrates that can be easily identified underwater. So that'll become important for our story here in a little bit. But so here we are today. Data entry was a really critical piece and any of the successful citizen science programs that are feeding data into science and conservation applications all share this story. They all have some well-documented, well-structured data management plan. There's a whole suite of citizen science programs that don't really have the end result of producing data that's going to be used. Those are more about engaging the public in science, increasing scientific literacy. So those don't necessarily have this. But any program that's successfully feeding data into the data stream that might be used by scientists and agencies must have something figured out. And for us, it was, in the early days, was optically read scan forms. In about 2007, we switched over to online data entry. We now have an offline program, too, that people can use when they don't have internet access. As I already said, there's several levels of built-in error checking, and that's been really important for us to be able to make sure that the data that ends up in our database is as accurate as it can be. So we have the experience levels, and then we also have many different avenues, as I already said, feeding into the training. So there's not just one step that people can do. So as Julia said, 214,025 surveys are what are in the database right now, 24 years later. It's a lot. 12,000 sites from around the world. The majority of those, I'll show you in a little bit, are from the Caribbean, the Western Atlantic. About 15,000 people have done at least one survey. The database is very large, about 9 million records, and about 3,800 species are incorporated in our database, almost all fish, and then those subsets of invertebrates in different regions. So that's a lot of data. So how do we get those data back to both the public, the general public who just want to get a glimpse of it, the users who are collecting it, and then the people who can use it, practitioners. So there's a couple of different streams that we need to think about. So to give you a sense of the scope of the, and going back to that early, the kind of the scales that are unimaginable, right? These are the tiny little dots are places where we have surveys from all over this side of the globe, and then this side's really hard to see because there's all these little tiny islands all over the place, but there's the Hawaiian chain and the northwest Hawaiian Islands and Raja Ampat and Indonesia, and so all around the world, about 13,000 surveys, or 13,000 locations, sorry. And an interesting thing about citizen science, and this is not just unique to Reef, is so we have 15,000 people who've done a survey. But then we have these people, it's the fanatics. If you know those bird watchers who travel places just to find one bird because they heard some bird was down at somebody's feeder, and so that's these people. So so this lady up here, she's one of about 15 of our surveyors who have done more than 1,000 surveys. And these guys down here are holding up their slates because in the Caribbean, a kind of a threshold is to find at least 100 species on one tank. So it's one-upping each other on how many species you can find. So they did a century dive. That's what that's called. These guys are on a trip that is all about doing surveys. So I lead a lot of these. This is actually one that was in Fiji. And there's nothing vacation about these trips. They're in beautiful locations, but people are working nonstop. They're up, they've got their laptops out, they're reviewing pictures, they're learning, they're going to seminars. So these people are kind of at the next level, our super surveyors. We can take subsets of them out, the really experienced ones, we call them advanced assessment team members, and they will often go and do special projects for us. We may get a contract from a resource agency to do a specific set of monitoring. And it may be fish, it may be the roving diver method, but then they'll go and do other things. So they're not willing to do transects early on. But these super surveyors, if they think and know that, Reef's been asked by an agency in Florida to collect data, they will spend time doing the transects, and they're very well qualified to do that by then. So our advanced assessment team gets used quite a bit for those purposes. Another interesting thing about what happens because of these super surveyors is the contribution to the overall, that 210,000 surveys. So the bottom is the percent of volunteers, and the y-axis is the percent of surveys. And so in total, we have 210,000 surveys and 15,000 people. So 130,000 of those surveys, about 70% of all the data we have been done by 381 people. So it's about 2.5% of all of our surveyor has contributed about 70% of the data. So that's really telling and not unique to Reef, but it's always an interesting story to share. I think it's great because we've introduced about 15,000 people to what it's like to collect data and enter data and look at the underwater world in a different way. But really, the majority of our data are coming from a pretty small group of very skilled natural quasi-field biologists. They might have been realtors or lawyers or teachers in their other life, but they've become really skilled in the field. So getting the data out. So we have online data reports. Anybody can go to the Reef website and generate all different ones. This happens to be a summary report for Fiji, what you're going to find, sorted from the most common down all the way to the really rare stuff. And it tells you how many surveys have been done in the area and expert versus novice. You can query it in a bunch of different ways. You can look up your own data. So this kind of feedback is pretty critical to keeping our members wanting to do more. They can go and look at their own data. These types of reports also get used by non-surveyors. They get used in the formal and informal education arenas to be able to practice data analysis with real data. So that's all on our website. But then it's the other piece of, okay, getting data out to the scientists and resource agencies. That's kind of where I'll finish up today and tell you some of the examples of the raw data, what's happened when someone writes to me and says, I would like the raw data, all of the data you have on parrotfishes in the Caribbean for all time. And so I will send them the data files along with metadata about the survey. So where it was done, bottom time, temperature, all the metadata that each surveyor collects. And I get contacted probably, I don't know, about 1 to 5 times a month for raw data. And it all comes through me. We don't have a portal or anything. But the reason we do that is so that we can, one, get them the correct data that they want, but also keep track of who's asking for the data so that we can feed that back to our volunteers, because they really love to hear when they know that people are using the data, and also kind of follow up as publications arise out of the requests. So it's kind of, as was stated at the beginning, it's definitely generated the largest, longest run data set on fish populations, marine fish populations in existence. As I said at the beginning, there was no set, this is why we're collecting the data. So we have gotten a really great understanding of fish distribution maps now through all of our regions, most specifically in the Caribbean region for sure. We've been able to look at trends through time, but there's been all of these interesting and some more unexpected than others or hidden kind of immersive things that have come out of data applications as people start to request data. So I'm going to go through some examples today. New species discoveries and invasive species, obvious ones, because once you start teaching people what to look for and what's out there and what's rare and what belongs and what doesn't, those things become pretty apparent to the skilled surveyor. Episodic events, data poor species. So I'll go through some examples. There's over 50 publications, peer-reviewed publications, that have come out using the Reef database over the last 20 years. So we are definitely kind of at the top end of the citizen science world in how much our data has been used and accepted in the scientific community, which has been really exciting to see. And it's certainly steamrolled as more and more papers have come out and people are able to see, oh, that's how you analyze those seemingly messy data. So we'll talk about that a little bit. All of them are online, so you can go and look. But I'll give you a smattering of, I don't know, about 8 today. So one of the most obvious ones pretty quickly was we started getting people finding things that weren't in any guidebooks. And sometimes they're just obscure things that were described but not in the common guidebooks that divers are using. But we actually have had about 12 new species that have been discovered by divers over the last 20 years that were just not in not known to science. And not little tiny, some of them are tiny and obscure. But this beautiful wrasse called the Mardi Gras wrasse was found by actually me and a bunch of the divers really early on in my flower gardens days. When I first started doing my graduate work there, we would have reef surveyors come on trips to help fund the boat so that I could do my other research. And we found this fish, and lo and behold, it ended up getting described as a new species, very flashy, very pretty, very out there. Just was nobody ever was looking well enough to know, oh, that's actually something that doesn't belong or isn't in a book, not known. So there are several other examples, but that's one of my favorite ones because I was a part of it. Okay, so this invasives, right? So this is a ticking map that started in '89, and this is the Pacific lionfish. So this is a species that's native to Indo-Pacific, and our surveyors started noticing them on their surveys and reporting them, and all of a sudden they started noticing more, and through the years it's completely exploded, and now the Indo-Pacific lionfish is a permanent resident of the Western Atlantic. They're not going to go away. But the reef data has been a critical part of tracking that through the years because we have surveyors in all of these different regions throughout the Caribbean. The data were able to help kind of track this explosion. And There's been a bunch of papers from the lionfish invasion, but this one was based on the reef data and looking really at the path and the pathways and analyzing how they, in both before lionfish were there and after. So that's that paper. It was published in Bulletin Marine Science in 2012. And those guys are mostly all in South Florida at the Fisheries Center there and University of Miami. So episodic events. So this is the invertebrate story that I'll share with you today. So as I said, in temperate regions, we included a subset of invertebrates in all of our temperate areas. And the Pacific Northwest region is our longest running one. 1998 is when we first started collecting data on about 50 species. We included, as I said, a whole variety of different ones, but keystone species, top predator, invertebrate predators, sea stars were on the list. And lo and behold, many of you know, I'm sure, that over the last, about 3 years ago now, I guess, there was a very rapid and severe die-off. A sea star wasting disease swept all the way down the west coast. And because we had baseline data from our program starting in '98, it's been a very interesting data set, useful for being able to look at the changes that have happened. And now as some sea stars are starting to come back, the recovery of those species. So 2 papers that just recently both came out looking at the sea star wasting disease using reef data and the baseline that we had going back. The top one from Schultz et al., that was in Peer J, and then these guys work, they're the CDOC Society and others. That one just came out more recently in PLOS One. So looking at the top paper, Schultz, they looked at what's happening with some of the other species, because in addition to sea stars, we also monitor several of the sea urchins. And so looking at which sea stars that weren't dying off might have gone up because of the die-off species, and then also what's happening with sea urchins. So that's something, of course, we could have never predicted, but having those data as a baseline then allowed them to be able to look at the effects of the wasting disease. This is a big one that, this is a big fish, and a big issue that's become really valuable for our data set is data that are either data poor because they're so rare. So in the example of like rockfish in the Puget Sound, or with this guy, the Goliath grouper in the Western Atlantic. In Florida, they've been closed for all take for quite a long time, over a decade. And so there's no traditional fisheries dependent data on Goliath grouper. And so there's every so few years, there's a fair bit of pressure that's put on the state to reopen that fishery, because it appears that they have recovered fully from where they were. They were almost gone from Florida waters. But so is that a reality? Have they really recovered to pre-closure, to pre-impacted states or not? And the reef data set, again, because these are very charismatic, you're not going to notice them, you're not going to misidentify them, a pretty reliable data set. And because we've been there the longest, since 1993, the reef data set is the data set that they use primarily to evaluate what's going on with Goliath grouper in Florida. So there's been several papers that have been published. They've been used in several CDAR assessments of Goliath grouper and other species. And this is just one example of a publication that used the data out of Chris Koenig's lab. But the other thing that I'll say about this is that it keeps coming up. It's like, every few years it kind of gets put to rest, then it comes back up. So having a data set that continues, it wasn't just like that one and done. Now it's if you're familiar with Florida politics, it's actually come up quite a bit again. And so fortunately, the reef data isn't something that's subject to grant funding or an academic, the lifespan of a graduate student. It continues on, hopefully, forever. So now when they come back and need data again, we've got 3 more years of data to add to their assessment. So a similar story for a little bit of a different reason are for rockfish out here in the Puget Sound. There are several species that have been undergoing potential ESA listing, Endangered Species Act listing, And so about 5 years ago, the folks at the Northwest Center requested data to augment. They did have some fisheries-dependent data, but augmenting it with our fisheries-independent data, and did a position paper then, 5 years ago, 6 years ago. And now, during the 5-year review, they got updated data from us, and also, this is actually not out yet, but it's in press. I think it's in press now. A time series analysis for estimating population trends for data poor species. So incorporating several different data sources, including reef data. So that's great. That's exciting. Not so exciting for the rockfish, but exciting for us to see the data use. So going back to the Caribbean and reminding you how that is where we got our start. And so the data base there is the longest. It's the most widespread with a lot of data from a lot of places. And so the last couple examples I'll share are these really big, the unimaginable scales questions that you could have not done previously, looking at basin-wide impact studies, looking at impacts of changes in climate through the years. So because the monitoring program encompasses fully and beyond species ranges, which often, almost never, do data streams encompass over the top of a species range. So then you can start to capture changes through time at the tops and the bottoms of their ranges. So a couple of examples. These guys just recently, well, a couple of years ago now, I guess, looked at additive partitioning. So really just basic ecological questions about what's happening with coral reef communities, fish communities in the Caribbean, and how diversity changes through different ecosystems. And a neat thing about this paper is actually a lot of the folks who are using our data in particular are US based, but these guys are actually scientists from the Yucatan area. One is from the academic institution there, and one is from the government agency, like the NOAA of Mexico there. So that was an exciting paper that came out a few years ago. Two others that were looking broad scale impacts of large predators and the impact that populations have and fishing pressure has on those. The top one was one that looked specifically at sharks, and then the bottom one was more of large predators in general, snapper and grouper primarily, throughout the whole range. So an interesting thing about the top paper, the sharks, they actually did sharks and rays. There were a couple of different papers that came out. During that process, Christine Ward-Page, who was at the time, she was a graduate student of Ram Myers, and she was crunching through data and noticed that this guy, the yellow stingray, which used to be ubiquitous, the most common and abundant ubiquitous elasmobranch that you would find on Caribbean coral reefs. They're a relatively small stingray that lives on Caribbean reefs. And she actually called me up, I remember, and said, you know, I've been crunching through these data, and I see a really almost unbelievably sharp decline in yellow stingray in Florida. What's going on? They're not fished for. They're not a commercially important species. Why would that be true? So this is actually what she saw. So this is between 1994, the things aren't on there, but 1994 to 2005, so 11 years, and basically showing a decline from 33% sighting frequency to 9%. So pretty significant. And so this paper that she ended up publishing, she started talking to folks and realizing that a couple things were happening to those stingrays. They were the young ones were getting collected for the marine life trade, so being used in aquariums, and not really regulated and kind of going unnoticed. And they were also they're really important species for biomedical research. So they were being collected for biomedical work, also not tracked in the traditional, so it was kind of going off the radar of a traditional fishery sense, but a pretty significant, because they were historically the most abundant, kind of mesopredator, small-bodied predator on coral reefs. So that was an interesting one to show that this type of data set, often as citizen science programs, have a broader scope. We're encompassing a lot of species, not just the commercially important ones or seemingly commercially important. And so this was a interesting kind of light bulb moment for a lot of folks in Florida that they might need to rethink some stuff. Okay, so messy data. Yeah, it's messy. It's big and crazy and uneven effort, and all different types of people are collecting it. So there was, for a long time, and that it is still an issue in citizen science in general, there's some resistance that, well, we can't possibly use those data because they're not collected in any sort of meaningful way. They're prone to errors. There's all sorts of biases. But fortunately, over the last 5 years or so, there's been a lot of work that's been done and really driven by some folks here at the Northwest Center and in this department to try and develop some new innovative quantitative tools and techniques that can take these types of data, whether it's citizen science or other types of more traditional data sets that might seem to be too messy for the original, the old school type of data analysis. So there's been several different papers that have used reef data to look at this. Here's just two of them. So Jim Thorson here, who's here today, thank you, Jim, has did some great work developing modeling techniques that could make use of these data, and the data set that they used was looking at 3 different species, including Goliath grouper from Florida. Ben Holt and his colleagues several years ago looked at how do our data, reef data, volunteer-generated data, compare with data that was collected in the same place using a more traditional transect method, and analyzing the differences between those, and both finding how they differed, but also how they can complement each other, and really, ideally, be used in concert to say something that otherwise you couldn't say with either of the data sets independently. A similar effort was done out here on the West Coast in California using PISCO data, which is a generated data set through the state-run monitoring program and through several different academic institutions, and reef data. So those are interesting, and that's really the story, being able to, again, it's not a catch-all, it's not here to replace anything. My hope is that it's just seen as, it's one tool in a toolbox that can help address a whole wide variety of questions and issues. So I'm kind of going to close here with, and I've mentioned some of the factors of success, why I think we've gotten here. I think definitely not a small ounce of luck, for sure. There's definitely was a little bit of that. And developing a protocol that was developed by the people who were going to do it. The divers were kind of the driving force, because the understanding of what is really doable, what is interesting, what people will keep coming back to do. But then that collaborative part of working to do some purposeful planning with people who are going to use the data, people who could help us figure out how to store the data and make it reliable and usable. So that methodology, the kind of early on work that was done, data management was key, as I said. Having this, really in the last couple of years, the explosion of both, social media and the ease of taking photos underwater and sharing them amongst people you've never even met. Everybody's got an underwater camera now, and that's happening both topside and underwater. So you've got people with cell phones. The explosion of what's happening, the abilities of people to capture snapshots of data on their phone and send them places, I think in the next 3 or 4 or 5 years, it's going to be really exciting to see where we get with this, just a whole open, if we are open to it, I think some really neat things will come. It definitely hasn't always been easy. Early on, especially, we got a lot of skeptics about, that, oh, well, that's a nice education program, good, nice, but, not really, we're not going to use those data. And also a lot of maybe, in some circles, fear that maybe citizen science was trying to come in and replace real science that was happening. And I think a lot of that skepticism has washed away through the years as people have come to understand the power and the role that it can have. So I think, here we are. It's been quite a journey to work on this program my whole adult life, really. And it's an honor to be a part of it and the growing citizen science community. I've known Julia for years. We've crossed paths thinking back to the very early workshops that happened. We had one in New York at the Natural History Museum a decade ago, thinking about how to, bring citizen science into the next level, the science of citizen science. People are talking about how does that work now. So I really appreciate you guys having me here. I appreciate you listening to me. I know it's really warm in here, so thanks for hanging in there. And thank you guys for inviting me, and I really appreciate it. So thanks. Yeah, that's a great question, and I think it has grown, and people do it who they're engaged in the program, and it's part of their recreational. So we're really not having to convince them, the data collectors. They would never dream of getting in the water now without a slate, and just like an avid bird watcher wouldn't walk through a forest without their journal. Convincing people that it's worth funding, that is a different question. Yeah. And we have relied on the volunteers to raise a bunch of money. We haven't gotten big funding grants all that well. I think the tide might be changing though, because there's so many good examples of how maybe in the past monitoring that was run by a government agency is really expensive. It's really expensive. Survey for survey, citizen science isn't free, and that is an issue that often is a kind of a thing that we have to overcome. It's not free, but it's definitely much more efficient and more affordable than a government-run monitoring program. So, yes. Yes, yeah, good question. So the question was about access and the cost of diving. It is definitely true that a lot of our volunteers have, expendable money to spend on traveling and doing, 1,000 surveys over 10 years. But there's definitely ways, especially we've been working with some communities in the Pacific, doing more on the ground, just getting them the first step of in the water, face in the water. And so there's been some really successful snorkeling programs, getting people just seeing what's in their local villages. And it is for our purposes, it's diving and snorkeling. So a lot of people end up just snorkeling. So a lot of younger kids, we do some education programs in the Keys specifically. Yeah, but it is always an ongoing, how can we reach out to younger communities and of different, origins and where they live and how far away they are from the ocean. Well, so how can we, someone who lives in Denver, what's the meaning to them? So trying to increase access, at least to the first step of learning more. So we actually do about 2 to 3 fishinars, we call them, a month now, which are about an hour-long online webinars on a variety of topics, and that's been a really interesting way. People will watch them as a family. People will watch them landlocked, and in their pajamas with their glass of wine, and they're, just learning little snippets. They're really short, and that's been a fun way to kind of, even if they're not a diver or snorkeler. So, yes.
Well, I guess clarification is one of the questions. So not only do your volunteers collect data for you, but they're willing to contribute money for the data storage and all of the things associated with putting that information out there. So if a federal agency wants to know your record over all of these years for some species of interest, do they at least pay you through a contract?
No. We've been asked that through the years, yeah, do we charge for data access? And we don't. And it's worked out okay for us. Yeah, so volunteers, it's free to participate. It's free to be a member of Reef. So a lot of people aren't even divers or snorkelers. They just get our education and outreach content. So yeah, we don't charge to do the surveys, but we do request donations a couple times a year as a nonprofit. So that's where we're getting, and a lot of people are most active surveyors don't actually donate or don't donate very much, because rightly so, they're making the calculation in their head that I've already spent $10,000 going on trips and X number of hours submitting data, and so that's my contribution. So yeah, but we don't charge for data access. Yes, Jen.
Sorry.
Okay.
You did a great job with the history.
I would offer you some water, but you don't want my water. Yeah, you want a moment? Okay, yes.
Maybe I'm going to ask the same question. It's really encouraging to see how far the region has come. So if there's a concept that you wish you had built in the program 20 years ago, or programs just starting out now, what would that be?
Yeah, that's a good one. Well, let's see. So 20 years ago, if I could have done something a little different, our origins were in Florida, and that's so our biggest core is there. But obviously we have this worldwide reach now. There is often a misconception still among people who don't really understand what we do, that it's a South Florida program, and so I guess if we could have done it a little differently, maybe early on, is make a little bit more effort to have some a little bit more regional office kind of thing, instead of putting all of our eggs into that South Florida basket. It turned out okay, and as a grassroots nonprofit without much of a budget for years and years, I'm not sure that it could have been a reality to have anyone, staff a few other places to really build up a program. We ended up pretty lucky, because we ended up for years, now we have some staff in a few places, really out here in the Pacific Northwest mostly, but we were lucky enough to identify people in regions that could they weren't paid staff, but they just kind of took it on themselves to get a local program started. Today, if I was getting started, the technology piece, the IT, that's a struggle. We talked about this a fair bit today. It's the expectation of the IT world of their pay scale is so beyond what we're, so just the concept of, of seemingly simple task costs a huge disproportionate amount of money. So some interesting today with the director of science for Coast, we were talking about this idea of, gosh, I can't remember what she called it now, but kind of hijacking, finding interested IT people. What'd you say?
Robin Hood.
Yes, Robin Hooding. To find those people who want to do good, so they'll go and kind of sell their soul a little bit and do some, not very interesting but really lucrative programming work, so that then they can offset and come work for, and kind of do a little bit of pair matching and matchmaking amongst those interested in really skilled people with good hearts and interest in some, so that we can start to capitalize more on that, because that's a challenge. There's so much we could be doing that we're not doing, and it's all because we don't have a programmer, we don't have a person that can do really crazy, awesome visuals, and so. Thanks for the question.
Jen, last question. I'm ready.
Or maybe not.
The history is amazing in terms of all the citizen science that has been done in the past, and yet things have not. So this is maybe the same answer that you just gave, but I'm wondering how much the technological revolution actually enables citizen science.
Yeah. I would say definitely it has. Because it seemed to really coincident with smartphones. A lot of them have platforms that are just solely based on smartphones. We can't do that because we're underwater, but a lot of those programs, those 1,100 programs, they're solely an app, that are tied to the fact that you have a GPS, an internet connection, and a phone all in one little tiny handheld device. So I would say, yeah, definitely.